Part A then wants us to sketch this function y equals 2x minus 5. So 2x minus 5 would be a graph that does something like this, crossing the x-axis down here at minus 5. So what we're going to do is draw the bit that's above the x-axis, and then when we hit the x-axis we reflect it back up, so we end up with a function that looks something like this. We need to know where it crosses the axes. Well, if it would have hit the axis down here at minus 5, it's going to cross the x-axis here at 5. And if we're looking at y equals 2x minus 5, then on the x-axis y is 0. So if 0 is 2x minus 5, then x is going to be 5 over 2. So it's going to cross the x-axis, or meet the x-axis, I should say, at 5 over 2. So part B wants us to solve 2x minus 5, modulus of, equals 15 plus x. So if I draw the graph of 15 plus x on my original graph, it's going to cross the axis here at 15, and it's going to meet my original modulus graph in two points. So in order to find this point here, this is the original bit of the modulus graph, so I'm going to solve plus 2x minus 5 is equal to 15 minus x, and in order to find the coordinates of this point here, this is the reflected bit, so I'm going to solve minus 2x minus 5 is 15 plus x. So let's start with this one first. So 2x minus 5 is equal to 15 plus x. So if I take x over to this side and the minus 5 over to that side, x equals 20. And then for the second solution, I'm going to solve minus 2x minus 5 is equal to 15 plus x. So minus 2x plus 5 is equal to 15 plus x. So x is on one side, numbers on the other side. So 3x is equal to minus 10. So x would be minus 10 thirds. So we want f of g of 2 here. So f of g of 2. So the first thing we're going to do is work out g of 2. So this is going to be 2 squared minus 4 times 2 plus 1. And this gives us minus 3. And then we're going to work out f of the answer. So f of minus 3 gives us the modulus of 2 times minus 3 minus 5. So this is the modulus of minus 11. So f of g of 2 is equal to 11. So at the range of this quadratic for values of x between 0 and 5. So the first thing I'm going to do is find the turning point here. And I'm going to do that by completing the square. So g of x is going to be x minus 2 all squared. Take away minus 2 squared, so that's 4 plus 1. So this gives me x minus 2 squared minus 3. So therefore my turning point, which is a minimum because x squared is positive, is at 2 minus 3. And then what I'm going to do is put my n values in here. So I'm going to work out g of 0, and g of 0 would be 0 squared minus 0 plus 1. And then I'm going to work out g of 5. So g of 5 would be 25 minus 20 plus 1. So this comes out to be 6. So from here I can see that my highest value is going to be 6 and my lowest y value is going to be minus 3. So my range is given by minus 3 up to 6.